Hey everybody, welcome back. Today we're going to start one of 2 days of graphing quadratic equations. Before we get started, what I want to do is take a look at the typical shape of a quadratic equation. You can see here with the line that's red, I'm going to darken it so that way you can more easily see it. Any quadratic equation that we graph should form this U-shaped graph. A lot of students want to try to make this U-shaped graph be a V, but that's not how it should look. It should always be a nice little curve. Sometimes it's a fat curve, sometimes it's a skinny curve, but it should always be a nice little curve with arrows on the end. So looking at our graph, quadratic graphs have some special things. The first thing it has is the point either at the way bottom if you have a smiley face graph, or the point at the way top if you have a frown graph. These are both called the vertex. So in the graph on the left, my vertex is 2, 8. And then on the graph on the right, again, my vertex is the turning point. This, in this situation, is -2, 8. Now these guys are pretty special. When you have a smiley face graph, the vertex is what we consider the minimum point. What that means is it's the smallest value that x will ever be. Likewise, when you have a frown graph on the right, that vertex is considered the maximum point. So that's the highest y value that your graph will ever get to. So moving on from there, the next type of key information that we have here is right smack dab here. These are both considered our y-intercept. So those are our y-intercepts. And if you think back to our definitions from last semester, the y-intercept is also known as where it crosses the y-axis. In both of these situations, it crosses at the origin, so point 0, 0. It doesn't always cross at the origin. Just in this situation, they're both crossing there. The next thing that we can look at are our x-intercepts. So let's see here. In this situation, we have one here and one here. These are our x-intercepts. Let's see, the point on my left is at 0, 0. The point on the right is 4, 0. And it's okay to have an x-intercept and y-intercept that's the same point. That's perfectly okay. The thing here is when we're talking about x-intercepts, we don't just call it x-intercepts. With quadratics, they have many different names. One of them is the roots. One of them is also solutions. Or you may even see it written as the zeros. So all of those mean the exact same thing. If we look at the graph on the right, my x-intercepts here and here, I have an x-intercept at -4, 0 and 0, 0. And remember, those x-intercepts can be labeled as roots, solutions, and zeros. Okay, so now that we discussed the key parts of a graph, let's go ahead and graph some of these. So, oh, I lied. Hold on, let's go backwards for a minute. When we're looking at the domain of it, this is talking about which x values we can substitute into our equations. It's always going to be -infinity to +infinity. So, oops, I wrote that 2 times. So it's always going to be -infinity to +infinity for the domain. Where things change up are our ranges. Remember, the range is from bottom to top. So looking at the graph on the left, the very bottom of my graph is right there. Where does that line up on the y-axis? Well, -5, -6, -7. It lines up at -8. So my range goes from -8, and everything's pointing up, to +infinity. On the right-hand side, my graph is quite a bit different. Instead, now arrows are pointing down, so it's going to start at -infinity. And where does it top out at? Well, it tops out at, let's see, this is 5, 6, 7, at an 8. So it goes from -infinity up to 8. So notice with your ranges, if you have a smiley face, the number comes first. If you have a frown, the infinity negative comes first. Okay, so now I think we're ready to move on to doing some graphing. When we're graphing quadratics, they're always in standard form. When we're talking about standard form, we're talking about ax squared plus bx plus c. That's our standard form. So whenever you're graphing quadratics, you always want to go ahead and identify your ABCs. That's the ABC of quadratics. So A is equal to, in this situation, the imaginary number in front of x squared is 1. If you look here, do we have a B value? Well, B is in front of an x and we don't have one, so it's 0. Same with C. Do we have a number with no variable? Nope, so that's also 0. If you look at the axis of symmetry, that's where we're always going to begin. It says x is equal to the opposite of b over 2a. So the opposite of b, well, b is 0, so the opposite of 0 is still 0 over 2 times a, which is 1. So that's 0 over, what's 2 times a? 2 times 1 is 2, good job. So it's just 0. The way we write down our axis of symmetry is x is equal to 0. So when we go to our table, this point is so extra important. It actually goes in the center of our table. We need to put that 0. So then when we're trying to figure out the vertex, the key here is we need to take what our axis of symmetry is and substitute it into our equation. So my equation is x squared. So to figure out what the vertex is, I'm going to take what x is, 0, and I'm going to square it. So what is 0 squared? Well, it's just 0. So in this situation, my vertex is at 0, 0. So that's the other counterpart of that graph right there. So now that I have this center point, remember this is our vertex. Okay, now that I have that point right there, I need to fill in the rest of my table. Well, you're going to choose the two numbers that come before 0, so -1, -2, and the two numbers that come after 0, so 1, 2. And then you need to substitute these values into our equation. So to remind you, our equation is x squared. So if I wanted to substitute in -2, don't forget to put it in parentheses. -2 squared is equal to, good, +4. Watch your signs. -1 squared is equal to, great job, a +1. We already have our vertex filled in. Now I need to substitute in 1 squared, which is 1, and I have 2 squared, which is 4. Good job. Do you notice any patterns? Yeah, we have our vertex. The 2 points on either side of the vertex are the same. The second 2 points on either side of the vertex are also the same. So when I plot these points, something kind of neat happens. So I have, let's see here, -2, 4. I have -1, 1, 0, 0, 1, 1, and 2, 4 again. So I get this nice parabola is what it's called. Some people call it a parabola because it looks kind of like a bowl, but that's the shape of my graph. So now looking at that graph, remember right here is my vertex. Is that the highest point or the lowest point on the graph? Good, it's the lowest. So we call that the minimum point. My y-intercept is where x is equal to 0. So where is x equal to 0? Oh, it happens to be the vertex. So 0, 0 is my y-intercept. Remember your roots, that's one of the names for the x-intercept. That's where y equals 0. So looking at your table, where is y equal to 0? Yep, at 0, 0. And there's no other places where we have that root of 0. And then you could also, instead of writing it as a point, you could just write what the x value is. So what is the x value? 0. Your domain every single time, -infinity to +infinity. But now your range, remember, start at the bottom. So if I kind of get out my little crayon for a second, I'm going to color every part of my graph right here. Oh, let's not use that color. Let's use this one instead. Okay, so I'm going to color every single part of my graph that has my picture. Oh, it keeps going up. The arrows are pointing up and up and up and up. So it just keeps going up. So where's the bottom part of my graph? Well, the bottom is at 0. That's where I start shading, and it keeps going on towards +infinity. So that's how I do my range. Okay, so let's go ahead and look at another one. So if we look at number 2, we're going to start with our ABCs. Remember, it's ax squared plus bx plus c. So what is a equal to? Good, -2. B equals, oh, there is no just plain x term. And c is equal to, oh, there's no number. So now that I identified my ABCs, I'm going to substitute it into my axis of symmetry. So the opposite of b, well, the opposite of 0 is still 0 over 2 times a. So 0 over -4, which is equal to 0. So my axis of symmetry is x is equal to 0. And where does that point go? You're right. It is my middle point, my special point. So now that I have that, remember you put it right down here. Now that I have that, I'm going to substitute 0 into my equation. So that is where I started. So -2 times, well, what is x? X is 0 squared. So what is 0 squared? Right, it's 0. So -2 times 0 is just 0. So my vertex again is 0, 0. And again, that's my vertex. That goes right there in the center of my table. Now that I know what my x values are, I have to do the 2 that come before and the 2 that come after. Okay, so now take a moment and substitute these values in for x. So for -2, I'm going to have -2 times -2 squared. Okay, so -2 squared is 4 times -2 is, yes, -8. So now I'm going to do -2 times -1 squared. All right, -1 squared is 1 times -2 is -2. Good. We already have our vertex done. Yippee. So now we're going to do -2 times 1 squared. Right, 1 squared is 1 times -2 is -2. Now, some of you might be saying, if I already know the numbers above, can't I just fill in my table with what I did above to below? That's fine, but I always say double check one point to make sure that you did everything accurately. So now that I have that, we're going to graph our function. So -2, -8, okay, -1, -2, good, 0, 0, 1, -2, and 2, -8. Notice my graph is now a frown. So since it's a frown, this vertex point is the highest part, so it is a maximum. Next up, my y-intercept, that's when x is equal to 0. So where is x equal to 0? Oh, happens to be a vertex, 0, 0. Your solutions, oh, that's another fancy word for x-intercepts. That's where y is equal to 0. So where's the spot in your table where y is 0? Now it says f of x, but remember that's y. So, oh, that's when x is equal to 0. My domain every single time. Good, -infinity to +infinity. And then finally my range, the bottom, notice if I were to get out my coloring tools here, let's go ahead and do some coloring. All of this has my graph. All of this whole area. But where do I stop coloring? At that 0 line. So starting at the very, very bottom, where's my bottom? At -infinity. And it goes all the way to where? At the 0. And that 0 does get a bracket. Great job. Let's go ahead and do one more problem. So looking at number 3, again, remember these are always in the form of x squared plus bx plus c. So identify your ABCs. What is a equal to? Not 0, right, it's the 1 in front of the x squared. B, the number that just has an x, there is none, so that's 0. In this case, we do have a c. What's the number with no variable? Good, -4. Now that I identified my ABCs, I'm going to jump to my axis of symmetry. So the opposite of B, well, in this case, B is still 0 times, or over 2 times A, which is 1. Well, 2 times 1 is just 2. 0 divided by 2 is still 0. So my axis of symmetry, again, is just x is equal to 0. Now I realize that all of these ones had x equal to 0 for your axis of symmetry. That's just for today. You're going to see problems tomorrow where they're a little bit different. Again, remember that this goes in as my center point. Now that I have what that is, I'm going to go ahead. Remember my equation was x squared minus 4. Well, now I know that my axis of symmetry is 0 squared minus 4. Well, what is 0 squared? Right, 0 minus 4 is -4. So my vertex is 0, comma, -4. Remember that all goes to the center of my table. So now what numbers come before? Yep, same as we've done, -1, -2. What numbers come after? Good, 1 and 2. And then we need to substitute these values in. So I have a -2 squared minus 4. Well, -2 squared is 4 minus 4, which is 0. Now I have a -1 squared minus 4. What's -1 squared? 1 minus 4 is -3. Again, notice every single time I substitute this in, I'm putting that number in parentheses. And again, 1 squared minus 4, well, 1 squared is still 1, minus 4 is -3. Okay, so I could pretty much assume that this one would then be 0. Now I'm going to plot my points. -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0. I can form my U-shaped graph, and I have it all graphed. So now looking at that picture to the right, here's my vertex, my turning point. Is that the highest maximum or lowest minimum? Right, it's the lowest point, so that is our minimum. My y-intercept is where x is equal to 0. So where is it equal to 0? At 0, -4. My zeros is where my y, remember y is f of x, where my y is equal to 0. So where are the places where it's equal to 0? Yeah, right here and here. So what are those x values? -2 and 2. Those are both zeros or x-intercepts or y or solutions. Any of those work. Domain every single time. -infinity to positive infinity, good. And then if I get out my coloring tool, okay, so here we go. All of this, oh, it keeps going because the arrows are pointing up. It just keeps going and going and going, and life is great. So where is the very, very bottom of my graph? Well, the lowest it goes is that -4. And then where is the tallest it goes? Well, it shoots up towards the sky, so that is positive infinity. Okay, great job today. If you have any questions at all, feel free to talk to your teacher. Otherwise, I feel like you should be ready now to go ahead and go on to some classwork. Thanks, and I'll talk to you soon. Bye.